Okay, here we have an electricity question. So we have the electric current is the flow of electrical charges through a circuit, and it wants us to complete the sentence using one of these words. So metals are good conductors of electricity because electrical charge is transferred by delocalized. So you've got to remember what transfers the current in metals. It's not going to be the whole atom moving. It's not going to be whole molecules moving because they're both uncharged. Ions or electrons. Ions are quite large. Electrons are what we talk about when we talk about electricity. We tend to say the flow of charges or the flow of electrons. So it's delocalized electrons. And the word delocalized means it's not held tightly by their atoms. Okay. Here we have three symbols, and this is just a recall question. So the cross, the circle, the lamp, a rectangle like that is a resistor. For this one here, see those arrows coming out? Those arrows refer to light, so it is a light emitting diode. Okay, here we have a nice box of information about a hairdryer, kettle, electric hob and a television. And this is a 4-mark question. So we've got what looks like a lot of space, but we shouldn't need all of it. So the table shows information about some electrical appliances. The mains voltage is 230. This has a maximum safety of 30 amps. And it wants to calculate the current. So on our table before, we have our power. And if we add all of them together, we get 7,360 watts. So we can now write this. Here our power equals 7,360 watts. Our voltage is 230 volts. And current is power divided by potential difference. So current, which is symbol I, is 7360 divided by 230, which will give us a current of 32 amps. That's only part of the question. This is the next bit. Explain why it is not safe to use all four appliances at the same time. Well, the current is greater than 30. It says here, maximum safe is 30. We've got 32, so it would be unsafe for us to use all four at the same time. Okay, here we have a diagram, power station, transformer, cables, transformer and house. This part here is the national grid. Transformer 1 is a step up transformer. Explain why it's in it. So with that type of transformer, it says what happens to the voltage. So the voltage increases. Because the equation P equals I times V, we know power stays constant. If the voltage goes up, the current must go down. So current decreases. This is the whole reason we use this step-up transformer. So if we have a less current, it's going to reduce energy loss by heating. And that's because power is current squared resistance. So if we reduce our current going through the wire, we massively reduce the power, so the energy per second lost. If we're now losing less energy, this will increase the efficiency of transmission. And transmission is just taking it from one place to the other. So that now leaves us with transformer 2. So transformer 1 will step up, transformer 2 is the opposite, so it is a step down, so it decreases the voltage. And in the case of the UK, to 230 volts. So that is the voltage that comes out of your plug sockets. There. Now we move on to a more efficiency-based question. So we have a power station of 900 megajoules of thermal energy released by burning natural gas. And it wants us to write down the equation that links efficiency, useful input energy transfer, and useful output energy transfer. So input is what we put in, output is obviously what we get out. So efficiency is equal to the useful output energy transfer divided by the total input energy transfer. To make sure you're using the words in their equations. So they've said useful energy input, useful output energy transfer, so make sure you get those exact words. Now we just have to work out the efficiency. So we've already said we gave 900 megajoules. Only 405 comes out. So we have to do our useful, which is 405 megajoules, divided by 900 megajoules. And because the units are the same, we can leave them as it is, and that will give us 0.45. Now you can convert that to a percentage, which is 45%, but there's no need, you can leave it as a decimal. Just remember, efficiency must always be between 0 and 1, which is between 0% and 100%.